Today we will discuss about Gram-Smith orthogonalization procedure. This Gram-Smith procedure is used to determine n orthonormal basis functions, that is pi 1 of t, pi 2 of t, pi 3 of t, and so on up to pi n of t, so that each of these psi of t, that is m finite energy signals, can be represented as a linear combination of n orthonormal basis functions. So as I said, Si of t is equal to summation j is 1 to n Sij by j of t. So where the value of I can vary from 1 to m. So this is the m finite energy signals we are expressing as a linear combination of n orthonormal basis function. So if I expand this by substituting I as 1, so I can write S1 of t is equal to S11 pi 1 of t plus S12 pi 2 of t plus and so on up to S1n by n of t. So I can call this as equation 1. Similarly, when I is equal to 2, I can write S2 of t. S2 of t is equal to S21 by 1 of t. S21 by 1 of t. So, plus S22 by 2 of t plus and so on to S2n by n of t. You can call this as equation 2. So like this I can extend up to the value of m, that is Sm of t is equal to, so now the value of I is m, so Sm1 of t by 1 of t plus Sm2 by 2 of t plus and so on up to Smn by n of t. And we know the integral 0 to t pi I of t into pi j of t into dt will be equal to 1 when I is. So now the procedure is, in the step 1, we need to set all coefficients in the equation 1 to 0 except S11 equal to, except x11. Okay. So set all coefficients Sij equal to 0 except S11 in equation 1. So with this I can write the equation 1 as S1 of t is equal to S11 by 1 of t. S11 by 1 of t. So from this equation I can write what is pi 1 of t. Pi 1 of t is equal to S1 of t divided by S11. The integral over 0 to t pi I of t, pi j of t into dt is equal to 1 when I equal to j. So with that I can write 0 to t. So when I equal to j, it will be pi 1 square of t into dt, which is equal to 1, and which is equal to, I can say, integral 0 to t. So pi 1 of t is S1 of t, that is I can say S1 square of t divided by S square 1 into dt. So now I can solve this equation for S11. If I solve this for S11, so S11 is equal to integral 0 to t s1 square of t into dt and square root. So, integral 0 to t s1 square of t into dt is nothing but the energy of the signal s1 of t. So I can write this as square root of E1, okay, where E1 is the energy of the signal S1 of t. So which is nothing but integral 0 to t S1 square of t into dt. So now I know what is S11 and I can find out the first orthonormal basis function, that is phi 1 of t. So phi 1 of t is equal to S1 of t divided by root of E1 is the expression for phi 1 of t. Then I can express the signal S1 of t in terms of a linear combination of n orthonormal basis function as, so S1 of t is equal to root of E1 into L1 of t. So in step 1, what we find is, we are finding the energy of the signal S1 of t. With that, we are able to find out what is the coefficient S11. So S11 is equal to root of E1. With that, I will be able to express S1 of t in terms of the orthonormal basis function. In step 2, I repeat once again, in step 1, we are setting the coefficients of Sij equal to 0 in equation 1 except S11. With that, we could find out what is phi 1 of t and what is S11. Then I could express S1 of t in terms of phi 1 of t. In step 2, we need to set the coefficients of Sij in equation 2 to 0 except S21 and S22. So set coefficients of Sij equal to 0 in equation 2 except S21 and S22. With that, I can write as S2 of t is equal to S21 phi 1 of t plus S22 phi 2 of t. S22 phi 2 of t. So let me multiply this equation by phi 1 of t on both the sides. Multiply above equation by phi 1 of t both the sides. So with that, I can write S2 of t into phi 1 of t is equal to S21 phi 1 square of t plus S22 phi 2 of t into phi 1 of t. As I said, we are multiplying this equation S2 of t by phi 1 of t both the sides and integrate over the interval and integrate over the interval 0 to t. So with that, what I can say is, if I integrate, that is s to 1 pi 1 of t into dt over the interval 0 to t, which is equal to integral, I will take s to 1 outside, 0 to t, then pi 1 square of t into dt plus s to 2 integral 0 to t pi 1 of t pi 2 of t into dt. So the value of this is equal to 1, because integral 0 to t pi 1 square of t into dt is equal to 1, and this will be 0 because it is an integration and product of two different orthonormal basis functions, that is pi 1 of t into pi 2 of t. Hence, I can write s to 1 as integral 0 to t s to 1 pi 1 of t into dt. So I will be able to find out the coefficient s to 1 by rewriting like this. Now let me set the intermediate signal as G2 of t. Let the intermediate signal G2 of t as S2 of t minus S21 pi 1 of t as my intermediate signal. So now I can find out, I know what is S2 of t, and I already found what is S21, and I know what is the value of pi 1 of t from the previous steps. Now I can find out pi 2 of t as G2 of t divided by square root of the energy of the signal Eg2 of t. Energy of the signal G2 of t. So like this, we can find the n number of orthonormal basis functions by generalizing the signal g of t. So I can generalize gi of t, which is equal to si of t minus summation j is 1 to I minus 1, then Sij pi j of t. So any value of I can substitute, and I can find out the required value of g of t. So I can generalize pi I of t is equal to gi of t divided by square root of energy of the signal gi of t to find any orthonormal basis function. So this is what is the Gram-Smith procedure to determine n orthonormal basis functions. So now let us take one example and we'll try to solve with that example, and let us try to express the given equation, that is the linear equation, as a linear combination of n orthonormal basis functions. So for one, so three signals are there. So first one is S1 of t, which exists over the interval 0 to 4 with a magnitude of 3. Then another signal S2 of t, which exists for the interval 0 to 2 into 2, the magnitude of 3. And another signal, which is S3 of t, S3 of t, which exists over the interval 2 to 4 with a magnitude of. So these are the three signals given, S1 of t, S2 of t, and S3 of t. So we need to determine the orthonormal basis function, and we need to express these three signals as a linear combination of those orthonormal basis function. So looking at this problem, we need to find out first whether all these three signals are linearly independent or not. So looking at this picture, what I observe is these three signals are not linearly independent. So I can obtain S3 of t by subtracting S2 of t from S1 of t. So S3 of t is equal to S1 of t minus S2 of t. So what it says is, here the number of orthonormal basis functions, I can say it will be less than the number of signals, find energy signals, because all these three signals are not linearly independent, because S3 of t I can obtain by subtracting S2 of t from S1 of t. This is one way, and we can look into this even other ways of getting some other signal also. So I can, this other way what I can write is, I can get S1 of t by adding S2 of t and S3 of t. There is also other possibilities there. So S1 of t is equal to S2 of t plus S3 of t. Like that, we may be having different ways with which I can find out one signal from the another signal by doing some mathematical operations. So let me consider the first case, that is, as I said, I can obtain S3 of t by subtracting S2 of t from S1 of t. So with this, as I said, the number of orthonormal basis functions will be less than the number of signals. So the first step, what I need to do is, I need to find out first the energy of the signal S1 of t, and then I can find out pi 1 of t in the first step. Step 1 is, so energy of the signal S1 of t is E1, which is equal to integral 0 to t S1 square of t into dt. So which is equal to, so S1 of t exists over the interval 0 to 4. Okay, substitute the limit as 0 to 4, and the value of S1 of t is 3. So I can say 3 square into dt. So which is equal to, so 3 square is 9 of upper limit minus lower limit, that is 9 of 4 minus 0, which is equal to 9 into 4, which is 36 joules, I can say. So this exists over the interval 0 to 4. So t less than or equal to 4 and greater than or equal to 0. So this is the energy of the signal E1. Then S11 is equal to square root of E1. So which is equal to square root of 36. So which is nothing but 6. So I could find out what is the value of S11. Next is finding the value of pi 1 of t. So pi 1 of t is equal to S1 of t divided by S11. So the value of S1 of t is 3 over the interval 0 to 4. So I can substitute 4 and the value of S1 is 6. So it is 6. So which is equal to, so 2 2s are 2 3s are. So 2 by 3 is the value of pi 1 of t over the interval 0 to 4. T less than 4 and greater than or equal to 0. So here the value of S1 of t is 3, not 4. I have taken the duration. So let me. So S1 of t value is 3. So it is 1 by 2. 1 by 2. So now I can write S1 of t. The value of pi 1 of t is 1 by 2. S1. So S1 of t is S11 pi 1 of t, which is equal to the value of S11 is 6 into pi 1 of t. So the first step, I could express this energy signal S1 of t as a linear combination of this basis function. In the same way, we can find out in step 2 the coefficient S21 and S22. Then we can express S2 of t in terms of S21 pi 1 of t and S22 pi 2 of t. Okay. In step 2, our aim is to find out pi 2 of t along with the coefficients S21 and S22. So we can first write the intermediate signal, that is G2 of t is equal to S2 of t minus S21 by 1 of t. So I can find out first S21, then after finding S21, I can find out what is G2 of t, then finding the energy of the signal, then I will be able to say what is pi 2 of t. So S21 is equal to integral 0 to t S2 of t pi 1 of t. So S2 of t exists over what interval? It exists from here. You can find out. Yeah, S2 of t exists over interval 0 to 2 with a magnitude of 3, and pi 1 of t value is 1 by 2 over the interval 0 to 4, and now I can write what is S21. So S21 will be integral 0 to 2. I am limiting because the limits to 2, because S2 of t exists only over 0 to 2, and pi 1 of t, though it is existing till 0 to 4, but the value of S2 of t is 0 after 2. That is why I am limiting the limits to 0 to 2. So the value of S2 of t is 3, and the value of pi 1 of t is the value of pi 1 of t is 1 by 2. 1 by 2 into dt, which is equal to 3 by 2 of upper limit minus lower limit. So which is nothing but 3 over the interval t less than or equal to 2 and greater equal to 0. So this is the value of S21. S21. So once I find the value of S21 as 3 for the interval 0 to 2, and for other values of t it is 0, then I can find out what is G2 of t. So let me find out S21 pi 1 of t. S21 pi 1 of t, so which is equal to, so S21 is 3 over a period 0 to 2, and pi 1 of t is 1 by 2, so which is equal to 3 by 2 over the interval 0 to 2 it is. So to multiply these two signals, we need to do the graphical multiplication, then only these limits will be clear. So first let me draw the signal S21. So as I said, S21 is 3. It is from 0 to 2. Its value is 3. This is S21. And the value of pi 1 of t will be 1 by 2 for the interval 0 to 4. So if I multiply these two, so this portion is only common. Right? The rest of the things is 0. So I can get it is 3 by 2 as the product of S21 by 1 of t. Then to find G2 of t, as I said, G2 of t will be S2 of t minus S21 by 1 of t. Even if I do that graphically, so S2 of t exists over 0 to 2, a magnitude of 3. This is S2 of t. Then S21 pi 1 of t is this. This also exists over the interval 0 to 2, then magnitude of 3 by 2. So this is S21 by 1 of t. The duration is same, but their magnitude is different. So 3 minus 3 minus 2, 3 minus 3 by 2 is equal to, so 6 minus 3 by 2. So it's nothing but 3 by 2. So the value of G2 of t is, the value of G2 of t will be 3 by 2 over the interval 0 to 2, which is equal to which is equal to 3 by 2 over the interval t less than or equal to 2 and greater than or equal to 0, and it will be 0 elsewhere. So I could find out what is the value of G2 of t. So once I find the value of G2 of t, then I can find out what is the energy of the signal. So energy of the signal G2 of t, G2 is integral 0 to 2, its value is 3 by 2, G2 square of t into dt. So the value of G2 of t is 3 by 2, so which is nothing but it is 9 by 4 of 2 minus 0, so which is equal to 9 by 2 is the energy of the signal Eg2 over the 9 by 2 joules over the interval 0 to 2. Then I can find out what is the pi 2 of t. So pi 2 of t is equal to G2 of t divided by square root of the energy of the signal Eg2. So which is equal to, so G2 of t, the value of G2 of t is 3 by 2 and square root of 9 by 2. So which is equal to 3 by 2. Then square root of 9 is 3 and then 3 by square root of 2. So which is nothing but 3 by 2 into square root of 2 by 3, which is equal to 1 by square root of 2 over the interval 0 to 2 is the value of pi 2 of t. So we could find out S21 pi 2 of t, and one more coefficient we need to find out, that is S22. So we can write the expression for S22. S22 is equal to S2 of t minus S21 pi 1 of t divided by pi 2 of t. So which is equal to, you know what is the value of S2 of t? So S2 of t is 3, which exists over the interval 0 to 2, and minus S21 pi 1 of t. So the value of S21 pi 1 of t is also 3 by 2. Then the value of pi 2 of t is 1 by root 2. So which is equal to, I can say the value of S22 is 3 by root 2. So this is the value of S22. So in the second step, I could find out three things. One is S21, second one is pi 2 of t, and third one is S22. So now I can express S2 of t as S21 pi 1 of t and plus S22 pi 2 of t. So I know the value of what is S21 and S22. So with that I can write S2 of t is equal to, so S21, the value of S21 is 3. So you can say 3 into pi 1 of t plus the value of S22 is 3 by root 2 into pi 2 over t. So I already expressed S3 of t as subtraction of S2 of t from S1 of t. So I know what is S1 of t and S2 of t. I can express S3 of t in terms of the basis function. So with that, what I would like to write here is, so S3 of t, as I said, which is equal to S1 of t minus S2 of t. So S3 of t is equal to, so S1 of t I have expressed it. Yes, S1 of t as S11 pi 1 of t, which is nothing but 6 pi 1 of t. So I can write that 6 pi 1 of t minus S2 of t is 3 pi 1 of t plus 3 by root 2 by 2 of t. So which is nothing but, so 6 pi 1 of t minus 3 pi 1 of t is nothing but 3 pi 1 of t, and this is minus 3 by root 2 by 2 of t. So this is nothing but S3 of t. So this is how we find the orthonormal basis functions, and we are able to express those three signals in terms of these two orthonormal basis function. So this is what is the procedure of Gram-Smith orthogonalization for determining the basis function. Okay. So with this, let me stop about this. So shall we discuss next topic in the next class? Thank you.